All right, going over assignment 17.5. 1 through 4, you're given the coordinates of A, B, C, and D, which are the corners of a fence. And it tells you that Q is the midpoint of segment AB, R is the midpoint of BC, S is the midpoint of segment CD, and T is the midpoint of segment AD. So we're supposed to find the midpoints of all the sides. You really only have to find the midpoint of AB because there's only one with that correct answer. But remember, to find midpoint, you average the x's and you average the y's. So you would add the 11 and the 3 that are your x's and divide by 2. 14 divided by 2 is 7. And then the 3 and the negative 11 that are your y's. 3 and negative 11 add to negative 8 divided by 2 is negative 4. So Q has to be 7, negative 4, and that is the only answer that has that as a choice. But again, you're just averaging your x's. So add would get negative 10 divided by 2 is negative 5. And then negative 11, negative 9 is negative 20, divided by 2 is negative 10. That's all you're doing over and over again. So from here on, we're going to be using Q, R, S, and T as our points, not A, B, C, and D. So number 2 says use Q, R, S, and T from the previous problem and describe what type of quadrilateral it is. So remember, in order to do that, you need the lengths of all 4 sides and the slopes of all 4 sides. So I first started off plotting points Q, R, S, and T. Make sure you plot your points correctly. That's vital to getting the problem correct. Now it may look a little bit like a rectangle, but remember, you got to go by information, and if you go by the information, it is not a rectangle. So finding the lengths of all 4 sides, I put in those coordinates. You can pause the video and check if you didn't get those correct. But you should find QR to be 6 square roots of 5, which is approximately 13.4. RS is 2 square roots of 29, which is approximately 10.7. ST is 6 square roots of 5, which is approximately 13.4. And TQ is 2 square roots of 29, which is approximately 10.7. So you see QR and ST are congruent. I can put tick marks there. And RS and TQ are congruent. I can put tick marks there. Remember, a different set of tick marks because not all 4 sides are congruent. So right there tells us this cannot be a rhombus because not all 4 sides are congruent. It also cannot be a square for the same reason. Finding the slopes, again, pay attention to your signs of your slopes. Q, R, and ST are both uphill lines, so you know they have positive slopes. R, S, and TQ are both downhill lines, so they have negative slopes. So Q to R, I would have to go, if I went from Q to R, I'd go down 6, left 12. Negative 6 over negative 12 reduces to 1/2. If I look at the slope of RS, going from R to S, I'd have to go up 10 and left 4. Positive 10 over negative 4 reduces to negative 5/2. S to T, I would go up 6, right 12. 6 over 12 reduces to 1/2. And TQ, I'll go up 10, left 4. 10 over negative 4 is negative 5/2. So notice that these slopes are not opposite reciprocals of one another. The opposite reciprocal of 1/2 is negative 2. The opposite reciprocal of negative 5/2 is 2/5. So we do not have right angles at these vertices, which tells me it cannot be a rectangle and it cannot be a square. So we've already eliminated rhombus, rectangle, and square. Since the opposite sides have the same slope, that tells me that these are parallel. So we have this pair of parallel sides and this side of parallel sides. So you have 2 pair of parallel sides and 2 pair of congruent sides. So that makes it a parallelogram, not just a general quadrilateral. Number 3 wants you to find the intersection of the diagonals. So remember, since it's a parallelogram, the diagonals are bisecting each other, which means they're going to intersect at the midpoint. So you could find the midpoint of Q to S, that's a diagonal, and the midpoint of R to T, and it should be the same point. So averaging those, 7 and negative 9 is negative 2, divided by 2 is negative 1. Negative 4 plus 0 is negative 4, divided by 2 is negative 2. R and T, negative 5 plus 3 is negative 2, divided by 2 is negative 1. Negative 10 plus 6 is negative 4, divided by 2 is negative 2. So that is the point of intersection. They're midpoint of both diagonals. Number 4 asks you to find the approximate perimeter of quadrilateral QRST. So you're adding these lengths here. So you have 2 of the 6 square roots of 5, and you have 2 of the 2 square roots of 29. So exact perimeter would be 12 square roots of 5 plus 4 square roots of 29. But if you put that in your calculator for the approximate perimeter, you'll get C. Number 5, again, you needed to begin by plotting and labeling these points, being very careful that you're plotting those correctly. Finding the lengths of all 4 sides by plugging those numbers in. Again, you can pause the video if you need to. You should get all 4 sides to be 2 square roots of 2. Finding the slopes, again, these 2 slopes are uphill, so they have positive slopes. These are negative downhill slope. So our slopes, rise 2, run 2 is 1. Same for AB, rise 2, run 2, which is 1. With CB and DA, we go down 2, right 2. So that's negative 2 over 2, which is negative 1. So since all 4 sides are congruent and opposite sides are parallel and consecutive sides are opposite reciprocals, notice that. So we have all 4 congruent sides. We do know that the opposite sides are parallel to because of those same slopes, but this is really important, recognizing these as opposite reciprocal. So the opposite reciprocal to 1 is negative 1, because if you flip 1 over 1, you still have 1 over 1. So that tells me the perpendicular relationship exists to have right angles here. So we have congruent sides and right angles. That makes this figure a square. On 6 and 7, you are finding the missing coordinates for N, and you are told this is an isosceles trapezoid. So we know this side has to be parallel to this one, and since this is a horizontal line, this one must be as well. So that tells me the y-coordinate has to be the same as that point. So that was pretty easy to find 7 to be 4. The x, since it's isosceles and these legs have to be congruent, we would have to create the same right triangles here in order for these lengths to be the same. They'd have to be congruent hypotenuses of those 2 right triangles. So we know if we create this right triangle, this length is 2, this length is 4. Change in x, change in y. So same thing here, change in y has to be 4, change in x has to be 2. So 10 minus 2 gives me the x of 8 for that point. Number 8, even though we were given that it's isosceles, we're going to show algebraically how the diagonals are congruent. So you're finding the length of M to O and L to N and showing that those are the same. So again, you can pause if you need to see if you went wrong somewhere, but this is plugging those into the distance formula, simplifying that radical. You get both of them to be 4 square roots of 5. So you showed that MO is equal to LN.